Yeah, I believe it is started. Yeah. So, good afternoon again. First, we just go for the recap, and after that, we will continue the remaining part. Last time, if you remember, we discussed about the threat modeling, and we discussed that what is the means threat modeling, what actually we require in the threat modeling, its overview, and then we discuss about one of its type, which is known as the stride. And you know that we discussed that the stride, each of the word is actually stand for something. And then we discussed about the different stages of the threat modeling. And we also discussed that when we can use or go for the threat modeling, means how we can go. And then we discussed about the different uh, flowchart science, and we discussed that the threat modeling is normally going to be done at the early stage, and also we discussed that we are following the SDLC and the other things. So we discussed about the threat modeling mainly, but we didn't discuss any case study or the sample about that, and how to implement considering any one of the sorry, any one of the core example, and then we just try to deploy or apply the threat model. So then we can see further that how it is working and how whatever we discussed last time. So that can be more accurate for us to understand that. So you remember that we discussed that it is start with the functionality, and we try to find out what to protect, and then we try to group them, and what are the high risk level, how it indicates, and what are the assets, what are the means domains, what we are supposed to means going to protect, and so many things. And then we came up. It's just only a recap, so that's why I'm just trying to show you just for a recall that these things may be in your mind while we start working, implementing for that, so you may not get confused for any of the concept. So stride, you remember that we discussed that each of the word is actually for some different, pointing to some different thing, which is like spoofing, tampering, repudiation, information disclosure, and denial of service, and elevation of the privileges. Then, sorry, then we know that how we identify and for what we actually normally identify the threat modeling scheme. Then we try to understand what is the threat, and we quoted a one very funny type of example from our real life to understand that what is the threat. And then we discuss about the what are the vulnerabilities, what are the risks, and what are the threats. So you know that vulnerabilities are the weaknesses in the system, which can be exploited by the attackers. And then we talk about a few of the examples about the DDoS attack, about the paper, which is vulnerable to the fire, gas station, which is vulnerable to the fire, and so on, and the other examples. Then we discuss about the risk, that we said the risk is nothing but it's the threat times the vulnerabilities. So means how much threat we have multiplied by the vulnerability. So this is known as the risk. Then in the threat modeling, further we discussed that how and where we can implement. So you remember we discussed that we can implement at the stage of the means STLC. So we will ensure that actually the design is implemented safely and securely. And then we also refer to your lab session as well, where you was trying to implement, design the thread model for the one of the very popular and famous bikes company, and whose design was stolen by the bad bikes, and so on. So just for your recap. And then we said that there are the different three approaches when we are going to design the threat modeling. The first of the approach is the attacker centric, where we just focus that how we can save ourselves from the attackers. Our focus will be on this. The second thing is about the software centric, that how our software itself is not vulnerable, or it is not open to the threats, and it can be easily handled. So that is the one of the model stride we talk about, that this is the means software centric approach. And today we will means go for the case study that is also about the software centric approach, and we will use the stride. And then the third one approach is the asset centric. So either we are focusing, means we receive a task from any company as a secure software engineer, so they are concerned about the assets, then our means focus will be how to save the assets. And if suppose it is the attacker centric, so then our focus is to how to save from the attackers. And the same way, if it is a software centric, then we go for the stride, how we can save the design from the six especially type of the attacks which are representing in each of the word of the strike. Then we said that how we can design, how we can go, how we can start the kickoff and identify the cases, and how we can do for this one. So you remember we said that for this we have to go, we have to understand, we have to read at the zero level about the requirements, about the system flow, what system is doing, what are the system requirements, how system is functioning. Because until and unless we will not knowing this one, we will not be able to come up for a proper solution to design the threat model, and we cannot be able to suggest anything. Now, when we are going to the threat modeling high level overview, then we discuss about the ASF, which is the application secure framework, and then we said how we design, how we come up with secure framework, and how we come up with the reports, and then how we suggest to the company, the concerned persons, what they are supposed to follow, so they can be able to get the maximum benefit of this one. Then you remember that we said that we actually do remember this one, because these things we will use today in our case study as well. So then we said that the three stages of threat modeling normally. So what these three stages are, we normally call them 3D. So the 1D is to decompose the application. Second D is the determine and rank the threat. Not only determine that where is the threat, but we also need to rank them. Rank them means prioritize them. That which one is actually threat is more higher, and which one is more lower, or which one is the medium level. Which one threat is necessary, required to be addressed, and which one threat is in between, and which one threat, the few of the threats they are means we can ignore them just with the warning, just with the cautions, just with the those type of the threats can be handled by the policies. So we have to rank them, and then we have to identify to the concerned people, and then we see that what they have about that. What they actually, what are their requirements about that. The third D was to determine the countermeasures and mitigations. So once we decide that these are the threats, after decomposing the model and after putting them rank, then we decide as well that for A to Z, what are the threats and how we can come up with the mitigation models for them. So this is how actually decomposition is there. And in decomposition application threat modeling, we do the data flow diagrams and come to pinpoint about the assets, external dependencies, and entry point and trust levels. External dependencies, like suppose most of the software, they are not fully operate, or not fully functional only from the internal input, but they have the external input data as well. So we have to identify, to understand their flow, understand their operations at the zero level, how it is, what are their requirements, because few of the requirements are very important. We cannot ignore them, and few of the requirements, they are normally also becoming a cause or reason for the threat as well. So we have to identify, we have to group them in our data flow diagrams, that what are the assets, what are the external entities, external dependencies, and what are the internal entities, and what are the entry points, and what are the trust level. So then we will be able to do the job in a better way. Now these are actually the diagrams. So you notice that a few of the things are a bit different from the flow diagram principles, but normally, basically, they belong to the same thing. So not to be worried, only the few things maybe you didn't use before, which is the trust boundary, process boundary, and the machine boundary. So you can see them that there is a difference of the colors for them. So these are the signs you can use, and you can identify the normally the threat model for any of the software, for any of the application, and then you will be able to identify what are the threats at what level, like suppose at the trust boundary level, at the process boundary level, at the machine boundary level, at the external entity level, or at the internal entity level, or at the process level, or at what level, and then you can even identify that what are the actually rank of those possible threats. Means the threats what you are mentioning, what are the means rank for them, like suppose which one is really compulsory to address, otherwise maybe our system will be highly vulnerable, and which one is means partially, and which one is means up to the warning level only. So this is very important, and we just go through the recap to means recall your minds, to refresh your minds that what we discussed, because these same things we will refer today while we are going to implement. So now be ready for the today's thing, which is the sample problem. Now we are starting for that. And I hope that, and during the recap, you got the idea about the previous one that what we discussed. So then we will not be facing any kind of the issue or problem while we are discussing this one. It's very simple. It's not something big deal, but we will be referring back to the things that what we recap and what we discussed in last week and right now. So be ready, and it's very simple. And in case if suppose you don't understand at any stage, please let me know so I can explain to you, because understanding is very important. So once you understand, you will clear your concept, then these things will be just like a 1, 2, 3. Very simple. Then you will be an expert. You can create a threat model for any other case. Say, for example, for any other case given to you that this is the issue, these are the information related to this one, or if suppose just for a test case, you can generate, you can create the possible requirements, and then you can come up with the threat model and can pinpoint exactly what are the threats and at what level the threats are. So it's very simple. Now, today we are going to discuss about what our task is. So you can say that today we receive a task where we are supposed to means create the threat model. So this is a case. Okay, so we are just going to read this one, as you can understand that for what we are going to create this one. Actually, we are focusing to the student result portal. So you can consider, you can say that this is the student result portal is for you, and this student result portal is for Taylor University. So this portal can be implemented at any state, means at any university. So first of all, as we said, that we have to know to collect the right requirements, because the moment we know the requirements, then only it will be easy, and for us, we will be able, it will make us able to means come up with the right threat model. If we are missing from the understanding the process of the software or the application, and we don't have the requirement, or we are missing from the some of the requirements, then our threat model will not be accurate, and whatever we will prepare, then maybe again we will be in trouble, because we will not be able to know that what we have done. Now you can see from here, you need to perform the threat analysis on the web application which manages the student marks. So what it means by the first point, it is saying that you need to perform the threat analysis. What's a threat analysis? This is a task for you. For what? For the web application. What a web application? It is the student marks portal. So this is your first primary task. What's the second point is saying? You have 3 users. So now you are knowing the understanding the flow of actually the users, the application. So what are the 3 users? Number 1 is the administrator, number 2 is the teacher, and number 3 is the student. So you consider the administrator, the exam unit. Teacher, instructor, you can consider the instructor, your instructors. Student, you consider yourself. So this is the real case scenario. Now you are trying to come up with the means threat modeling for this real scenario. So the next point, the user should log in the application and perform their respective task as follows. Now, this third point is giving you actually the requirement. You remember I told you that we have to understand the process, we have to decompose the 3D, we have to understand the requirements, we have to understand the operation of the system, then only we will be able to implement this. We consider this application because this is the one most common application which is being used by all of the students. You are already user for this, you are already knowing that how this application is working. So about its process, about its flow, about its requirements, you are already aware about that. That's why we took this one, as you can understand the things very simply and easily. So now you can see the third point is mentioning us that the requirement. What are the requirements? It means suggesting us the user should log in to the application and perform their respective task as follows. We have three users: administrator, which is the exam unit; instructor, consider me myself; student, consider you yourself. So requirement is all of them is to means log in the system first, and then they are able, they should be able to means get the operations done. What operations? Administrator is the user who will maintain the application and does not perform any other action. Exam unit will not enter your marks. Your instructor will enter your marks. Exam unit will not means decide on the basis of the grades that who is passed, who is failed, who has the means grade A, who has the grade A plus, or who has the grade F, or who has what percentage and who has how many marks in what component of assessment. This is not the job of the exam unit. That's why what he's saying that it only application does not perform any other action, but it only maintains the application. How it will maintain? To make sure the maintenance of the application, it is working fine. Any new instructor is coming, so they can give them the rights, the assigns, the modules to the assigned modules, not to the means anything extra privileges to anyone else. So they make sure that they are maintaining the application in all of the aspects. Fine. Going back to the next step, it's the teacher. Can view, yes, can view, can enter, can modify the student marks. So teacher can view, teacher can enter, and can modify as well. What do you mean by the modify? Because if suppose he made a mistake for entering the marks for student A, he entered the marks for student B, because when he's entering the marks, there are so many students, especially for those classes. Like suppose we have in accounts and business, I have learned that in the one of the module, they have in 100 of the students. So there are the possibilities that while they are entering the marks, probably they enter the marks for Mr. C to Mr. D. So now they have a right to means edit that one. They can view to verify that what they enter, the marks, they are correct or not before they finalize the results. Okay, student. Student can give his means register number and view the marks. So students are only supposed what to do, that they can only view the results. They are not required to means edit anything. They are not required to manipulate anything. They are not required to play with the system, but only to view the marks. You need to understand these three things very critically, because based on this process, based on these requirements, your whole threat model will be based on that. But we are going to design now. So it is very important that you have to understand the requirements, the operation, the process of that system for which you are supposed to going to design the threat model. Now, going next, perform the threat modeling on the application by making an initial assumption that none of the security feature exists in the application. Now, once you are knowing that these are the users, these are the requirements, this is the process, this is the application. Now you are supposed to come up with the threat model. So the moment when you start designing a threat model, even though the company is suggesting to you that they have a security feature here, 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 but you just take them all null and void. Why you are taking null and void? Just in a minute, I will explain you why. You consider that none of the security feature exists at that moment. You are the one who is considering the system from very bottom, from very scratch. Then you are the one who will suggest that what security level or layers should be at what stage actually. Then once you suggest, and then you will see when you discuss to the company, to the concerned people. So while briefing, you will automatically find out that what level are already available and what levels are missing. So for the missing level, you can suggest. So always, while you're going for the threat modeling, at that time, you will always consider, this is the primary requirement, that none of the security layers are there. It's a very bottom level, scratch level system on what you are going to work. Once you're done with this one, it's a very informative and very necessary, slide which contains the information. Like you need to understand the process, you need to understand the requirements, and even before you need to understand what is the application, and then you even need to consider the flow of the operation, and also the role of the actors, what they're doing. And on top of that, now while you're going to design the threat model, you just consider that none of the security layers are there. Once you're done with this one, then we are going to the next slide. Now this is the Microsoft SDLC threat modeling tool. You can find so many different tools. You're not supposed to use only the Microsoft SDLC threat modeling tool. There are so many different tools you can find, and then you can use it. No restriction on that. So now you can see from this tool, this tool is actually designed for the specifically for the threat modeling. So you can see at the title bar, new model 1 SDLC threat modeling tool version blah 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 blah. Maybe you can find the new versions as well. So now in this, you will find that from the left to right, the second vertical pane, this is containing the threat modeling different instances. So these instances are the actual, those signs and flow diagrams, the flow diagram components, that what we just discussed a couple of minutes before. So you can find here, I hope that you can be able to see my mouse pointer. So you can find here process, external, and the interactor, multiple process, data store, data flow, trust boundaries, process boundaries, machine boundaries, and other boundaries. And they all are dependent on the colors. Now see here, this is just a simple, you can say this is the user, these are the commands, these are the responses. User at this stage, just for your primary understanding, could be any. User could be teacher, could be administrator, could be student. So it sent the commands and it received the responses. And then you can see this is the boundary here. This boundary is what? This is in red color. Go back and see this boundary is the trust boundary. So then it is going to the processes. Then it's going to the configure and it goes to the data. The whole process is going to be occurred on the data. Then the results are coming back, processing it happening here, and then finally you are able to receive the response. This is not the threat model, but this is just only a sample for you to understand it, how it is working. Now we are going to design the threat model, what case is given to us. Okay, ready? Okay. Now just see here, use cases. What use cases? Entire architecture, administrator use case, teacher use case, authentication use case, registering use case, entering mask use case, displaying mark use case. Why is discussing about so many only the use cases. You remember we discussed that while you are going to design your threat model, you are going to design your threat model at zero level. At zero level. Going back, remember that. So you're going to go for the zero level flow diagram. That's why you need to define what are the use cases possible. Entire architecture, one is for the entire architecture, which means have the details for all of the web-based system which is providing the marking entry. Administrator use case, the exam unit use case, what they are supposed to do, what they have the privileges, and how they perform and everything. Same thing for the teacher, because this is the one other actor. Same thing is actually for the student. And then you need to have some of the authentication use case. Like suppose privacy software is designed, so for sure there should be some of the authentication mechanism or processes there. So you need to see that as well, that what is there previously applied, but you are considering that there is no security mechanism is here. Registering use case. How the teacher will register first time, how the student will register first time. Why we need this? Because maybe at this stage, at this level, there is some kind of the vulnerability or weakness. So read the whole from all of the aspects. Entering marking use case, while the teacher is entering the marks, how the teacher is entering the marks. We need to know about that use case as well. Displaying the marks, how then marks are going to be displayed as well. So we need to know about that as well. Means for each and every step, we need to know all of the information. I hope you understand. Now going ahead, you can see one more sample. This sample is actually for displaying the marks. So you can see the user, and I just use the mouse pointer so it will be easy for you to understand. So you can see from here that this is the user. User can enter the mark. For displaying the marks, will be going for displaying the mark. This is the actor, which is the student. So a student can see the mark, or even this is the instructor who is entering the marks and then displaying the marks, or even this could be the process of displaying the marks for the whole entire system. So you need to understand with the different aspects so you may not have any confusion finally. So see from here, user request, then this is the number 2 is the also from here is the request, here is the request. So this is the student, this is the teacher. So it means the teacher is requesting to view the mark. A student is also requesting to view the mark. So it means this is the use case for displaying marks process, not for the any of the actor. If this is for one actor, then it could be only the one option is there, not the both of them. Okay, no problem. Go ahead. So what's happening now? Here is the firewall. So how it is happened? Your request will be going through the HTTP request. Why it is going to be the HTTP request? Because it is the web-based application. So then your request is going to the network and you will find here firewall. So before the firewall, come back and see this is the dotted line. This line is actually a trust boundary. If you forget, just go back and see from the tools what we discussed here in this figure. Even if you forget, you can see and hear what we explained, that what are the colors for the trust boundary, process boundary, machine boundary, any other. So you can see from here that this is the red color. So this is the trust boundary. So why it is a trust boundary here? Because we are saying that this is the users, who is the student or who is the instructor, they are the trustworthy users. What do we mean by trustworthy user? Trustworthy users means they are known and registered users. The teacher belongs to the tailor. The student belongs to the tailor. The student is not a general student. If a general student cannot come to this level, if a general instructor cannot come to this level, so they are the part registered part of the system. That's why we are saying this is the trust level. Fine. Going ahead. Now here you can see this is the firewall, and after the firewall you can see that this is the application server. Because when we pass the firewall for the tailor ICT, and then we are going again towards the application server. When we reach to the application server, now here you can find out the JDBC and the response, but response will be later. First, we can see that this is the JDBC which is going to approach the database. What is the JDBC? JDBC is actually Java connection string for the connection. Okay, so database connection. So this is the Java database connection, so we call JDBC. This could be any, this is only the sample. It's not necessary that should be the JDBC. It is not necessary that should be the HTTP and firewall and everything. This depends on the system process where it is implemented. But we are considering this as the one of the example, which is for the Taylor University, and we are considering that this is the web-based application, and it is. So that's why we are reading this one, so you can understand it well. The reason is because the system, the same system you are also using, so you are familiar about that. Now, once we reach here, after the application server, when we are approaching to the database, so you can see that this is an again means a sign which is with a different color, what you see here. You know, this is the means trust boundary, but this boundary is for what? This boundary is for the machine boundary, because beyond this, the operation is going to be done with the machine. Bring back to give you a simple hint. You just see this color, which is the blue color, is showing the machine boundary, and you can also verify this from here. So from these signs, you can find out that this is the machine boundary. So beyond this, now this is all about with the machine boundary. So it is not supposed to be means done anything else after this means state. So now you understand actually that where is the trust boundary, where is the machine boundary, where is the process boundary, and why they are. We need to define these boundaries because those boundaries actually help us to decide the level of the securities. Then beyond this boundary, what level of the security will be? Between these boundaries, what level of security will be? Like I'm just giving you the one example. Before the trust boundary, here we are looking only for what? We have a security layers, what type of? Maybe so many, but the most important one is what? That is the authentication. Like we make sure that this trust boundary, before this trust boundary, the user, sorry, which is the student or admin or the teacher, whoever is this, they must have login authentication, access control. So now you can say that this is the level, this is helping us, these boundaries are helping us to decide what security measures we need at what stage. I hope you understand. So, sorry. So this is the whole means simple phenomena for the simple case, and this will help because why we're doing this? This is still not the threat model. This is the means primary initial work what we are doing for the threat model. We are going to design zero level diagrams. Okay, go ahead. Now you can see from here. Here is defining us. See from the top row, this is actually stride. So you know the stride is what? The stride is the one which is software centric model, which is software centric approach, not the model, which is a software centric approach model. So in this, it means we are using what we are considering the security measures, finding out the vulnerabilities, making it more secure to our software, to our process. See now here, this is stride. And now this is stride, what it means. So this stride means snooping. S means snooping. This all means each of the letter is representing the same message that we have done. That's why we were doing the recap, as you can understand. This is elevation of the privileges. This is DDoS attack. This is reputation. This is spoofing. So don't you feel that this is the only stride. Come down on this way. Means this is in horizontal mode. When we come to the vertical mode, so you can see that these are the assets. These are the signs. You need to understand that these signs are for what. Okay, go back and see, from this figure or see from the sample what we discussed, that these signs are for what. This is for a process. This is for an external entity. This is for a database. This is for the boundaries. This is for the multiprocess and so on. So in the asset is what? The asset is actually, that is our Taylor's applications. They are our asset. So now on this side, they are assets. And these assets are actually we say that they are on a trust level. We are considering that there is no spoofing from this one. No spoofing from external entity, because why no is a external entity? Because we say that they are under the trust level boundary and the users are already having authentication. They need to follow the authentication. They are registered users. So for the process and external entity, there is no spoofing. In the same way, for the other points, what possible things comes under the trust level. So this trust level actually deciding that these things, due to the trust level, we consider that they are not there. I hope you understand. So this stride is actually representing to all of the attack in horizontal, and in vertical you can find out all of the assets. And because we are saying these at the trust level, so we are considering that they are not having this at this. Again, this is, we are doing our primary level study to pinpoint, to find out, to design the threat model. This is not the threat model still, but this is the process of threat model. Before that, this all is actually the process of threat model. Going ahead, now you see what the stride matrix we have. We need to follow the stride matrix by keeping in view that what are possible things of the process. Say for example, this is, we are applying one of the same process that what we just discussed, one of the process. Which process? For displaying the marks. If you just allow me, we just go here in this slide. You can find out that this is the displaying mark process. So we are just considering the one entity, one process, just to define you and how we can design the threat model. Because there are so many other things. You remember, for administrator, for instructor, for the student, we are taking this one to understand it how we are applying. Now, when we just go back to this one, so this is stride matrix. So now here we mentioned the stride is the spoofing, tampering, reputation, information disclosure, denial of service, elevation of the privilege, the same thing. But on a vertical side, see with my mouse pointer, this is the same numbers. Teacher, student, firewall, application server, HTTP request, response, JDBC, response, HTTP. up to the 14 number. What is this 14 number? This is the 14 number. You see 1, 2, 3, 4, 5, 6, 7, 8, 2, up to 14. So we are trying to break this one and apply the stride model on this one. We're just trying to pinpoint, find out that at what level, what possibility could be. Spoofing can be done at what stage? Firewall, application server, as a teacher, and at the student. Yes, this is possible. This is possible, then spoofing can be done there. But spoofing cannot be done at level 6, HTTP request 7, step number 8, step number 9. So all steps are free from the spoofing. So it means that we are supposed to make safe these 4 entities safe from the spoofing. So this is the one of the thing means coming towards us, the resulting that from the threat modeling study that this state is vulnerable for spoofing. So now this is our job to suggest it how we can make the spoofing means better. Like you see in ATM machines, while we are going to use the ATM machine, so while the user is entering the PIN code to take the money out, that is the ideal point for the spoofing. Any other person who is standing behind the rope, so they can try to spoof, or someone can use the hidden camera to spoof that what the keys you are entering. So later they can. So you notice that the ATM machines, they are trying to protect it in a different way. They are trying to vertically they are trying to place the sum of the cover or the sheets. So while your hand is entering the number, so no one is able to see. And then they are suggesting us so many instructions. Then while you are entering your number, so you have to make sure that no one is here. You keep your hand on up, and no one is watching you, and blah blah blah, and so on and so on. And it's important. Don't you think that only the person who is standing behind you is spoofing? Sometimes malicious peoples, sometimes hackers, they try to install the hidden cams on the ATM machines. You will not be able to see that, very small. So they are trying to watch it, what the number you are entering. Your PIN is what you are entering. So the better is that you have to be taking care. So that spoofing can be done at that stage only. In the same way, in the stride matrix, you can see that the spoofing can be done at this stage. Our vulnerability of the spoofing is at this stage. So then how we are supposed to keep that safe. Now in the same pattern, where we can see the tampering. Like suppose for tampering can be possible. Now rather to read, we are just going to say the numbers. So it is easy for us to get it easily done. So the tampering is not possible at number 2 and number 3. But tampering is possible at what stages? The rest of all of these stages, tampering is possible. But there, the tampering is not possible. So now you see the difference. Which thing is possible at which process? So this will give you a clear message that why actually we when to come up with a 0-level diagram for this process. Because that process now completely in front of us, and then we can be able to decide what level can be vulnerable for what. For reputation, what level? The same levels what are possible for this spoofing. Information disclosure means the teacher and the student themselves, they will not keep telling the passwords to anyone, but after that means all of the stages are vulnerable to the disclosure of the information. Denial of service will not be having attack on the teacher and the student, but for the rest of the steps, but it will be not on the response. So you can see the denial of service for number 8, it is not there, because that is the one which is trying to stop accessing. So once you access, then you can have the response back. So there is no DDoS rule there, a denial of service there. So in the same way, elevation of the privileges, that is at the application server and the firewall. If suppose we give the extra privileges and the other things on the firewall and the application server, then any user can misuse it. So now this is the complete scenario in front of us. Now we can suggest them that let us know how you are handling this spoofing at this stage. Let us know how you are handling the tampering at this stage. So then we go back and see that how they are handling already. Are they addressing properly or not? If they are not addressing properly, then what are the means lacking? What are the weaknesses there? So if some of the thing is missing from some of the point, then based on this model, so we matrix, we can let them know that this is the weakness point is here. So they have to address that particular point. Okay. Now, threat analysis. Is student able to modify the marks? Like see this one. Teacher may not be logged off the shared means the teacher log in and maybe then forget to log off. No proper input validation, SQL injection could be there. No authorization could be there. No output encoding accesses could be there. Process scripting could be there. So for these are the points, possible points we have to see the threat analysis. That either the student maybe they have the more access and we need to make sure that they don't have anything that they can modify or change or update the marks. So this is now means we are going in a sequence to know what role or what actor should have what rights and should be able to do up to one stage. Simple. So we're going ahead. So this is how we are actually designing the threat model. I hope you understand. I hope you understand. So you can analyze, you can come up with the metrics, you can have the trust levels, you can have the sample, so you can design your threat model. So now these all things come, then we can see that this is how our threat model is working, so on. So this is the sample problem is done. Now we are going to the other model. Threat model, there is no only stride model, but there are other models as well. So just going quickly with one more model. This will be just to give you the brainstorming understanding that you may not think that we only have this means stride model. Stride model is, you remember we said that there are the different approaches, and this approach having the software centric. We also have the two more approaches. Now see, this is the another which is known as the DRAG model. The DRAG is the risk ranking model. So you remember we said one is the asset oriented approach, one is the risk oriented approach, one is the software oriented approach. So this DRAG is the risk oriented ranking model. And the DRAG is stand for what? DREAD, and each thing is representing to the one like the same for this stride. D is damage potential. R is the reproducibility. E is the exploitability. A is the affected users, and D is the discoverability. So notice now, these all of the 5 points, they are actually pinpointing to something else. They are not like this, right? No spoofing here, no DDoS attack here, no extra privileges here. But these things are something different. Why? Because these all are pinpointing to the risk. So that's why this is risk-oriented approach model. That's why it is all entities are different and they all are pointing to the risk, either damage, either reproducibility, either point of exploitability, either affected how many users in case if suppose that their risk is there and going to be means expired, and what are the discoverabilities and so on. So this is how you need to understand that what is the difference between the stride and the DRAG model. Okay, going ahead. Now for this, we are not going to implement the same like case study to discuss because that was the only for the stride, so you just understand. But here we just give you the quick example that how it is working. So you can see the threat malicious users can view and modify the marks. Now if we apply the damage, because this is now we are applying the DRAG model to means pinpoint the risk. Okay, sorry. So the damage potential threat to the reputation is 8. Say, for example, we calculated. There are the 8 points where the threat to the reputation damage potential is there. Reproducibility is at the 10 points from our model while we design, and exploitability is actually set to 7 points. And the affected users will be how many? Say, for example, 10. And discoverability can be found easily that it's 10. How it is coming, we're not going in a detail, but we are just coming to the chunk just to give you the level that how threat model is working. So now overall score, you can see from here with my mouse pointer. So this is 8, 10, 7, 10, 10. So we just put it here, 8, 10, 7, 10, 10, 10, and we make them together and divide it by 1, 2, 3, 4, 5. So this is actually the average. So the average value when it comes to 9, so this is the overall threat score. So it means the 9 is the risk level, which is the higher. So we may have as low this average value as it is possible. This value is low, it means our system is more secure. This value is going higher, then it means that our system is on high risk. So this is how we are calculating the risk using the threat model. Now, you remember we said that we are supposed, as a security engineer, we are supposed to understand the flow, understand the requirement, and apply the 3D, decompose them. Then we are supposed to come up with the zero flow diagrams. Then we are supposed to apply the model, then what we are looking for. Say, for example, software-centric approach, then we apply the STRIDE model. Then we come up with the flow diagram. Then we come up with the matrix. Then we come up knowing that what are the weaknesses and what these things are. Then we also apply for the risk, the threat model, and we come up, we knowing that what are the risks now, how much is the risky and how many values are there, blah, 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 blah. Okay, fine. But now the thing is, the last point, which is the most important point, mitigation. Based on this information that we calculated as an expert, how to mitigate that one. How to mitigate that one. And how to come up means the suggestions to the company. Now you can see from the threat model, this is the spoofing, tampering, blah, blah, blah. This is the same thing in the matrix. If you just see here, this is the same thing in the matrix, spoofing, tampering, blah, 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 because it's the STRIDE model. And these are the findings what we have. Now we are trying to give the mitigation for this one. What is the mitigation? So for spoofing, say for example, what are the threat types and mitigation techniques? Spoofing identity, appropriate authentication has to be required, protect the secret data. Like I gave you the example of the ATM machine. Tampering with the data, again, we need to apply appropriate authentication, authorization methods, hashes, and digital signatures, and to make them tamper resistant. So for all of these things, whatever the issues we found here, we pinpoint here in this slide, which is actually the matrix of the STRIDE. Now we are trying to come up to give the suggestions, mitigations, that how they all will be control. So you can see from here, that is the last one, the elevation of the privileges, run with the least privilege. Means maybe the users, they have more privileges. So we need to suggest a company to reduce their privileges and just give them what the privileges are required, not more than this. So this is our finding. The company is assigning a job to us just to get this thing, which is the mitigation. But we cannot reach to this mitigation until and unless we cannot go to the whole thing what we discussed today. That is all about the threat modeling, to follow these all things and then to come to the mitigation. You notice it's very simple, step by step, it's easy, but it's highly important. Trust me, it's very highly important. Because if suppose some of the software is vulnerable, then they will be in a big trouble. Even you cannot imagine all that. So this is how we are supposed to discuss that. Now, you remember we said the security ASL. security controls. So you remember what is the security control ASF? I'm just taking you back, which were our means last time what we discussed. Here is the ASF. This is the application security framework. Now, when we come to the mitigation, then what is the next? Then we are means having the means security frameworks. So that framework may suggest them authentication, authorization, cookies management, and data input validation, error handling information, logging auditing, cryptography, session management, and everything. That framework will be derived from where? From this mitigation. This mitigation will be derived from where? From this, 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 and from this, and from this. This all will give us a solid background for mitigation. And this will lead us to the secure framework. That will suggest about all of the things to the user. About mitigation, authorization, cookie management, blah, 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 whatever these things are. So I hope you understand the things. So now we are discussing one more quick sample. There was the one of the sample for the threat modeling, which was actually for the means displaying the marks. Now this is another. This is actually about the mobile threat modeling. The users what we are using the mobile. So we are just going quickly. You can means this is only the 2-3 slides. You can means go in depth to understand and compare this one with the model what we have means already gone through. I'm just giving you the quick tips and hints. So see from here, again, this is the user. The user goes to the mobile application directly. Then the third-party applications are enterprise web applications, and then we are going to the data. But how it is working? So you can do it for your practice only, not necessarily for any submission, but just do it for your practice. This will make you means more strong to play with the threat modeling and to design the threat modeling models in your lab and everything and everywhere. Now going ahead, mobile threat model means for this one, you can see the more tips and these things, spoofing, tampering, reputation. So this is means the strike. So this is the possibilities for the mobile threat model that. So again, these are the hint for you. What are these things? How you can means make the matrix up from this one. Information is given already. So you just do the practice. Just try to come up means make one of the matrix for it and try to put it where it is, where it is, where it is, what it is, goes to for this one, for this one, for this one. Just do the means 10 to 15 minutes practice for you. Just to if you will do the practice means today, then these all of the concept will be means concrete and fixed in your mind. Then the conclusion will reach. Implement threat model or modeling in the SDLC. Remember, I told you in the lecture one, we will not leave the SDLC. In the whole course, we will not leave the SDLC because security is for the software. This is secure software system. Any system is built from the software. Any software is built on the SDLC. So we are supposed to always focus on SDLC. So you notice we discuss about the threat model is also at the 0 level. Now the next lecture, which is supposed to be done today, but this was very important. So you also notice that even we discuss in these things, when it's important, then important. So I'm not keen that give you the more contents, but I'm keen that you understand and clear concepts, which is the most important thing. Not to be worried about that. We will discuss in the next class. So the next lecture is about the risk management. This is the threat modeling. The next is the risk management. That we are supposed to discuss today, but because this is very important, that's why I try to come up with all the aspects so you can understand. So the risk management we will discuss in the next class. So threat modeling cuts down the cost of application development and identify the issues during the design phase. Do you know it is recommended that while you are going for the software, after the requirement phase means it is better that you need to contact the security professionals so they can design your threat modeling, do the threat model at that stage. Why? The reason is, if suppose you follow at that stage, then you will, believe me, I will show you the statistics in upcoming lectures. You will save your cost. Most of the companies, they do the mistake. They don't follow this. They just follow the other requirements, complete the software. When they are in trouble, then they come back to you, to the security. You are the security specialist. Please, we are facing this problem, or it is. Then again, you will take them back. What we did now for one of the system. Then you will suggest do this. Then they are supposed to contact to the companies back. The companies will say, we will not do it for free for you. We already deliver, our contract is end. This is the major changes. If you require, pay us money. So then you will see the stats will show then the cost of the software sometimes is 2 times, 3 times, or even more. So it's essential that everyone need to follow the right principles. Third point, it makes the analysis simple because you can reuse the data flow diagrams in future. So as a security engineer, if suppose you are trying to use making the threat model at the initial stage, then you need to do that in a more clear way, as you can later also use these contents. Once the software is ready, once it is testing basis, operational basis, at that time you can also, before the final deployment at the beta version, you can also do again and just verify that everything is addressed or not, or something is missing, then you can catch them up at the right time. These are the credit goes to these so many resources. So you can see that OWASP, this is the very important resource for the security. Trust me. And maybe the one of the most of the lecture about the testing and verification and validation. I will share with you the sheet of the questions in the upcoming lectures, and you will be amazed to see that how much work they are doing. This OWASP is not only for the secure software system. This is the platform for the security. For any type of security, this is especially designed for the security. This is for the security professionals. And the data which is available there, it is not only the blocks, but this all data is the industry data, tested data, and it is the real and live studies and live data. Very highly important data. It's not only the websites. They also provide you a lot. The yesterday labs, what we discussed, that was also a part of the OWASP. They are the industry partner. So I trust and believe that you may go and create your account with the OWASP, and you will receive the notifications for very current things from the OWASP. So this is something very important. So that's why we have to give the credit. Anyone who is the professional for the security and suppose he does not know OWASP, I cannot believe that. So something very important. And the other resources what we use, like Microsoft.com, which we use for the security modeling and the tools what I showed to you. And in the same way, the other different things are the resources also there. For mobile threat model also, we took it from the OWASP. You will never find the most of information in the books, because if suppose the book is released today and you are the one who purchased the first copy, it means that book took the 6 months in the printing and publishing and marketing. This is the normal pace. And then at least 1 year it took in the hands of the editor to write. So if in the first copy of the book what you have in your hand today, you can consider that it is at least 1.5 years, 1.5 year old. And you know that in your area, how speedy the things are changing. But this OWASP and all of the resources, they are for the security professionals. If you find today, it means it is maximum 1 week. So all of the labs for this course is also designed in line with OWASP. So all of the things you are doing, they are in line with the industry as well. So enjoy your course, and thank you very much for bearing me for so long. So thanks for you. And we are done. And the next, which is the risk management, we will continue in the next lecture. I have another lecture right after a few minutes. So I hope that you understand the things. If you have any question, please let me know. Meanwhile, I can go for your attendance.
Sir, I have one question.
Most welcome.
Can you go back to slides number 20?
Just 1 minute, huh? I already stopped sharing, maybe. Huh? 1 minute. Give me 1 minute. Where it is? Let me just stop now.